This is Mr. Ashton going through the Mathematics Numeracy Higher Tier Non-Calculator Unit 1 paper from the November or autumn of 2017. Because it's the higher tier paper, I've already done the intermediate paper, and the last 5 questions of intermediate were the same as the first 5 questions for this paper. So if you want to see the first 5 questions, there's a link below and you can go to the intermediate paper. Okay then, so without further ado, let's have a look at the first question that was on higher, which is question number 6. It says, Daniel has a pizza to share with some friends. After he has taken his share, he calculates that he has 0.83 recurring of pizza left. Daniel shares what he has left equally between 3 of his friends. Calculate the fraction of the whole pizza that each of his 3 friends will have. Give your answer to fraction in its lowest terms. Okay then, so the first thing we're going to do is start working through these as sentences. They've been put in order to help us, okay? Now we're talking about a decimal here, then the rest of them are fractions. So let's change that into a fraction. So the first thing we're going to do with a recurring decimal like this is we're going to write it out as x equals 0.83. Recurring means 333. So we actually take the recurringness, we actually go and physically write that in. Now notice I left a line there. There's a reason why I left a line. It's because there is 1 dot there I'll times by 10. If it was 2 dots, I'd times by 100, and 3 dots, I'd times by 1,000, and so on. 1 dot, I times both left and right side by 10. X times by 10 is 10x. And then 0.833333 times by 10 will shift everything along one place in terms of its place value. Okay then, so now I have 10x is equal to that and x is equal to that. I subtract these two things. So taking away these two guys, the 3's are all going to cancel. They're all going to cancel all the way down here until we get to this bit here, which gives me 3 take away 8, which I can't do. It gives me a negative answer, which I don't want. So I steal 1 from there to get a 5, then a 0.7, and then 10x take away x is 9x. To write that now as a fraction, I'd have 7.5 over 9. Now there's an issue with that at the moment. That is not a fraction because it has a decimal as the numerator. So what I will do to begin with is I will times both top and bottom by 10. Now there's no decimal. And it did say here it wants it to be in lowest terms. Now I might do that at the very, very end. It says he has 0.83 as a recurring as a decimal of pizza left. So that's how much that is a fraction, okay? So this is how much he has left. Okay, then he shares this equally between 3 of his friends. So because he's going to share this equally, what I want to do now is do 75 out of 90 divided by 3. Now that's not quite so easy when you write it like that. We prefer to be dealing this with fractions. And if I divide by 3, it's the same as timesing by a third. Effectively using the dividing by a fraction there, this is effectively 3 over 1. So it's the same as times it by a third. So then I can say that is 75 out of 180. No, that's a lie. It's not 180 at all. It's 270. 90 times 3 being 270. And now I'm going to start cancelling down that fraction. So first of all, I can see that 5 will go into both of those. How many times does 5 go into 75? 15. And then 5 into 270. Well, we know into 100 would be 20. 200 would be 40. And then 14 added on to that. Because it goes into 70 14 times. And then from there, I know 3 goes into both those. I know it goes into 15. And if I add together 5 and 4, we get 9. So therefore, it must go into 3 as well. So that would be 5. How many 3's go into 54? Don't know. So let's just check by here. 18. So we have 5 out of 18 for each friend. Okay, can't cancel down any more from there. Okay, then over the page, it says blank page, and then we go over again. So we're going to need to look at this as a double. Okay, now before I've even read anything, I've seen a bar chart and I've seen frequency density. So this is a hard bar chart. It's not a bar chart at all. It is a histogram, which it tells me here. Now, as soon as you see the word histogram, you should be thinking of the following formula. Frequency density is equal to frequency divided by class width. And just like speed, distance, time, I tend to write this in a triangle because you commonly have to rearrange these in the numeracy GCSE, okay? So we're told the times taken by a group of pupils to answer numeracy question were recorded. The histogram shows some of the results. So we can see there's my histogram with a missing bar. It says the remaining 16 pupils took between 25 and 35 seconds to answer the question. So we can see that's the bit that's blank there. Complete the histogram. Okay, so I need to go and work out what the frequency density is. So by cancelling that down, it'd be the frequency divided by the class width. Now we're told that it was a remaining 16 pupils, so that tells me what the frequency is. The class width goes from 25 to 35, so that's a class width of 10. So the frequency density would be 16 divided by 10, which is 1.6. So ruler 1.6 is quite a nice scale. We can see there we've gone up in 0.1s. So it's literally just going to be 1 up from 1.5. So that would be my missing bar there. Now, in terms of what that bar is, I think it's always handy to go and write in the frequency above it if we've just gone and worked it out, because at some point we'll probably need to know how many are in each bar, okay? Now, the next question says, what is the greatest possible range of times taken by the pupils to answer this question? So we know that range is the highest value, take away the lowest value. So the highest value that it could have possibly been is somewhere between 35 and 50. So let's say it was the 50, and the lowest value would be this value here, which would be 5. So it would be 50, take away 5, which would be 45. That is the highest it could possibly be. Okay, so not turning this one over yet because it was a double page. I'm assuming they'll want me to go back to it. It says calculate the total number of pupils who are in the group. So as I said, using this formula here to work out the frequency, we do frequency density times class width. Non-calculated paper, so I'm assuming there'll be nice numbers. 35 to 15 is a class width of 15. So 35 to 50 is a class width of 15. And frequency density of 1, so there's 15 people in this bar here. This bar here has a width of 10. And then 10 times by 2.4, I'm going to make it. Yes, 2.4 would be 24 people in that bar. Now this bar is quite high, but it's also quite skinny. It goes from 10 to 15, so that's a width of 5, frequency density of 5. 5 times 5 is 25. And then this one here, a width of 5 and a frequency density of 2, so 5 times 2 is 10. Okay, so the total number of people was 10, add 25, add 24, add 16, add 15. Now when you're adding this up, look for the number bonds. We like those two guys together because they make 40. Here, these two guys also make 40, and then 10 makes 90. So it makes it much easier to add up if you can spot the number bonds. They usually pop that in there for us. Part D says, Gareth was one of the pupils in the group. He says, let me try and read that again. The time I took to answer the question was 18 seconds. This means I was in the fastest 50% of pupils. Explain how Gareth's statement could be true. You must use calculations to justify your answer. Well, first of all, 50% of 90 would equal 45 pupils. Okay, we've got to know where he is roughly. And then he's taken 18 seconds. So let's go and actually look to see where that is on the histogram. So if we look for 18, we can see it'd be 2 squares down from 20 there, 18 here. Okay, I'm just going to go and put that as a bar. I'm just going to go and fire that up there. Okay, now he's saying that he's in the top 45%. Okay, now so far we know that 10 and 25 people, so a total of 35 people, took under 15 seconds. Okay, so I'm going to say 35 people were under or quicker, I suppose, than 15 seconds. Okay, now the next set of 24 people took somewhere between 15 and 25. Okay, so they took somewhere between 15 and 25. They could have all taken 15, they could have all taken 25. We don't know, we've just assumed that it's just been evenly distributed, that they're sort of doing it 15, 16, 17, and so on. Okay, so how could he have been in there? Well, 10 pupils, within 10 pupils here, and he's there, okay, which he probably is looking at the distribution of that bar. If there's 24 people in that bar there, it seems fair that less than 10 would be there and 14 would be this side, some sort of split like that. So I think the way I'm going to word it from there is that because 35 people were quicker than 15 seconds, 18 would be in the next category, and he would need to be and he'd need to be in the first 10 because it's 35. He'd need to be in the first 10 pupils in that category. He would need to be in the first 10 people in 15 to 25 seconds category. Okay, we're then asked, how could this statement be false? Well, it's exactly the same idea. If most of the people, if it wasn't actually a fair, even distribution, and actually lots of people finish straight after 15 seconds, then that could be the issue, okay? So I'm going to say, if most people finished within 15 to 17 seconds, or I say if most people, it should be if more than 10. Then claim is false. Okay. Right then, so let's just tidy this up a little bit so we can now see. Okay then. Question 8. Have a quick read of the question. I'll start to go through it in a moment. Okay then, it says a company produces two similar road signs. Now they've bolded the word similar, so I know I can go and work these things out in terms of scale factor. That is a linear, a straight line, so I can start to work out what the scale factor is in a moment. It then says the cost of the paint needed for the smaller road sign, so the cost of the paint needed for the smaller road sign is £1.60. Calculate the cost of the paint needed for the larger sign. Okay, now, when we're talking about similar shapes, there should be three formulas that you remember. Small times by the scale factor will give me the big one. Now that is for a line. The small times by the scale factor squared will give me the big one. Now that would be for an area. And then the small times by the scale factor cubed will give me the big, and that would be for volume. Okay. Now, first of all, we can see we have 30 and 45. They are lines, so I can use this formula here. Because I know the small line, the small width, and the big width, I can work out what the scale factor is. So I'm going to say 30 times by the scale factor will give me 45. If I then rearrange that to 45 divided by 30, I can find out that the scale factor is 1.5. Now, from here, it says the cost of the paint needed for that. So the paint is going to cover all of this. So that would be an area. So I now want to use this formula to go and work that out. It says the cost of the paint, so for the small sign is £1.60, times by the scale factor squared, so times by 1.5 squared, will give me the cost of the big area. Okay, just move the camera so you can see clearly. Now, 1.5 squared is 1.5 times 1.5. So if you don't know it, you can split it like this. But I would expect you to actually know what 1.5 squared is. If you don't worry, just go back to methods like this to help you. 1 times 1 is 1. 1 times 0.5 is 0.5. 1 times 0.5 is 0.5. And 0.5 times 0.5 is 0.25. Add all those together, you get 2.25. So I need to do £1.60 times by 2.25. And again, I need to go and work this out in terms of doing something similar to that. Now, rather than actually partitioning it to be two sort of bitty, so e.g., I'm going to do 2 and I'm going to do 0.25. I'm not going to do 0.2 and 0.05 because 0.25 is a quarter, so basically I'm just dividing things by 4. I'm now timesing that by £1.60. So as I said, I'll use that trick that I just said, that 0.25 is a quarter, so I'll divide things by 4. 1 times by 2 is 2. 1 times by 0.25 is 0.25. 2 times by 60p is £1.20. And then a quarter of 60p would be 15p. So adding those all together will give me £3.20, £3.45, £3.60. Okay, so the total equals £3.60. Okay, question B I thought was an absolutely horrible question for a non-calculator paper. It's hard even if you had a calculator here, but you don't even have a calculator. It says, the selling price of the smaller road sign is £12. The selling price was calculated from the cost price by adding a profit of 25%, then adding VAT at 20%. Calculate the cost price of the smaller sign. You must show you're working. Okay, so in terms of this question here, you need to know how to work out multipliers. The cost of the smaller sign, the cost, so the price of selling the smaller sign. So we know that we've got a cost price. We then add a profit, so we times that by 1.25, and then we would add on a VAT at 1.2, and that would give me the selling price. That's what's happening there again. That's why I thought this question was hard. It's hard to know to do that bit first like that, okay? So the cost price times by 1.25, then that answer times by 1.2 to give the increase of 25%, then an increase of 20%, will give me £12. Okay, I'm not going to put in the, it's too late now, I'll have to say £12 at that. In fact, actually, I'm just going to cross out and say £12 at that. I'm now going to divide both sides. So cost would equal £12 divided by 1.2. If you're unsure, you can use equivalent fractions here. You can times top and bottom by 10. Say it's the same as doing £120 divided by 12. And 120 divided by 12 would be 10. But I've missed the times by 1.25 on both of those there, which I shouldn't have. I've just divided by 1.2 so far. And now I need to do the cost. To find the cost, I need to do £10 divided by 1.25. Now again, not easy to do. I'm going to use equivalent fractions here. So let's make that, I'm going to times it by 100 to get rid of the decimal completely. 1.25 there becomes 125. So it's 1,000 divided by 125. Couple of different ways I could do this. I could divide top and bottom by 5, but I'm actually going to write out the 125 times table. So 125, then 250, then double that would be 500, then double that would be 1,000. So I've doubled again. So 2 times 2 times 2, that's 2 cubed. The cost price is £8. So if I go and add on 25% of 8, I would go and get £10 and then times that by 1.2, I get £12. So working through, yes, that all works out fine. Okay, then over the page, we're told that two runners, Katrin and Delith, start a race at the same time. The velocity time graph shows their velocities over the first 5 seconds of the race. So we can see that Katrin has gone much faster because it's much steeper, and then she's come to more or less a stop because it's gone flat there. And in fact, she's slowed right down here, and then she's started to run slower than she did to begin with, okay? And then Delith has just taken a very steady increased speed up, okay? We're asked after the start of the race, what is the earliest time that Katrin's acceleration was 0? Well, Delith's acceleration in the first 5 seconds is never 0. She's getting faster and faster and faster the whole time in that first 5 seconds. But as we're looking at Katrin, we're looking at this graph here, and we're looking for where it's flat at the earliest time. Well, it's flat in a few places. You can argue that it's flat there, but the earliest time where I see my ruler absolutely parallel to the x-axis is there. So I just want to come off and read that value, which is 2 little squares on from 1.5, so it would be 1.7 seconds. Okay. Over the page, it says, use the trapezium rule to calculate an estimate for the distance Katrin, so we're still working with the curve one, travelled in the first 5 seconds of the race. Use Katrin's velocity at times t0, 1, 2, 3, 4, and 5. You must show all you're working. Okay, so at 0, we fire a line up till we hit the graph that's already there. Then we do the same at 1, fire up until you hit the graph. Same at 2, all the way to 5. Okay, so what we're doing is we're splitting these into what are general trapeziums. They're not quite trapeziums because of this curve, which means it's not going to be hugely, well, it's not going to be perfectly accurate. Although they're quite narrow strips, so the more strips you have, the more accurate it would be. And I have area A, B, C, D, and E of Katrins, okay? Now, the first shape isn't a trapezium at all. It's a triangle. So the area of a triangle, we do a half of the base. So the base goes from 0 to 1, that's 1. Half of 1 times by its height, which I make that to be 4, okay? So a half of 1 times 4, 1 times 4 is 4, half of that is 2. So in the first 1 second, she travelled 2 meters. Area B, now that is a trapezium. And we need to know what that number is, which is 5. So our formula for trapezium is a half of the parallel sides. So that would be this side here and this side here. So 4 plus 5. And then times by a height of 1. So times by 1. So basically we just need to do 4 add 5, which is 9. Half of that is 4.5. Times that by 1 is still 4.5. Now, because I finished on 5 there, for area C, I know it's going to start off with 5 there, because that bar is shared with B and C. And then this number here, I need to be really, really meticulous when I work it out. I can see it's 2 little squares down. Look at the scale there. That would be 4.8. So basically, we want the average, what's in the middle of 5 and 4.8, and then times by 1 still keeps it the same, so that would be 4.9. For D, it's going to be a half. We ended on 4.8 there, so we're going to start at 4.8. And then here, that's 4.2. So we want to know what is in the middle of 4.8 and 4.2. So that's 4.6, times it by 1. Still 4.6. No, hang on. No, it's not. It's 4.5. And then for area E, that finishes on 4. This one's a little bit easier for me not to get the answer wrong. It's going to start on 4.2. We're going to times it by 4. And then times by 1, so that's 4.1. Okay, we now need to work out the total distance. We need to add all of these together. Look for number bonds. There usually are number bonds here. I can see 4.5, 4.5, so that's 9. And then I can also see 4.9, 4.1, so that is also 9. 9 and 9 is 18. Add the 2 would be 20 meters. So she covered 20 meters in the first 5 seconds. We're then asked to calculate how far Katrin was ahead of Delith after 5 seconds. Well, we need to go and work out what Delith's distance is. So her distance is just this lovely triangle. So its base is 5, its height is 3. So we need to just do a half of the base times by the height. So 5 times 3 is 15. Half of that is 7.5. She travelled 7.5 meters. So it'd be 20 take away 7.5. So she's 12.5 meters ahead. It then says, explain why your answer to C is an underestimate. So if we come to our answer to C as an underestimate, it'll be to do with Katrin's distance. If we actually go and look at putting these, the first one is a triangle. That's fine. That's a perfect triangle. But if we then look at making those trapeziums, you can see there that the trapezium every time, certainly here and here, and a little bit here, is a little bit smaller. That area that we've estimated is slightly smaller. So I'm going to say by using trapeziums in Katrin's area, we have slightly missed areas that she has run. So she would have run further than 20 meters. Not a huge amount, like 21 maybe, not a huge amount. We'd have to work that area right there, but that's why. Okay. Okay then, over the page. Now, a bit surprised to see this come up again because the key word we've already seen today, similar. Okay, so we're looking at using the same formula again. So let's have a quick read of the question. It says, the diagram shows 2 similar flasks for measuring liquid. The flasks are in the shape of cones. The smaller flask has a base radius of 8 and a vertical height of 20. It then says the larger flask has a base radius of 14. Calculate the vertical height of the larger flask. So this is using exactly the same maths we've already used in this paper, which is really strange. We're looking for corresponding lengths that we know are the same. We're told the base radius of each is 8 and 14 respectively. Because they're both lines, I can use my small times by scale factor is equal to my big one. Okay, so I know that 8 times by the scale factor would give me 14. So I can work out that the scale factor must be 14 divided by 8. I'm going to write that down, or I'm going to cancel that fraction down ever so slightly to make my life a bit easier. I know that can cancel down to 7 over half that, 7 over 4. So basically, in terms of lines, I've times that by 7 over 4. And to work backwards, I would divide by 7 over 4. Now I want to work out the height, the vertical height of the large flask. So they want me to work out what this distance here is, and I know the smaller one is 20. Okay, so I need to now do 20 times by 7 over 4, and that will tell me what the vertical height of that is. I'm going to use this like a fraction, and make that 20 over 1, and then I can cancel down that 4 goes into 25 times. So then I can do 5 times 7, which would be 35, and I can do 1 times, this would effectively be 1. You've divided top and bottom by 4. 4 divided by 4 is 1. 20 divided by 4 is 5. 35 over 1, so that would be 35 centimetres. Okay? Now, going from here on to the next question, it says the larger flask is now partially filled up with liquid up to a vertical height of 15. Okay? Now, we still know certain elements of this because it's the larger flask. We know that the entire height from here to here is 35 centimetres. We just worked it out because it is the larger flask. And we know that the radius here to here was 14. They told us that in the last question. It's then asked us to calculate the volume of the liquid in this flask. So I want to know what the radius of this little guy here is. Okay, so we're looking at this within a scale factor in itself. Okay, effectively, I've got a big triangle where I know that's 14 and I know that's 35, and then with the same angles because it's within there, I've got this is 15 and I don't know what this is, so I'm going to call it x. Okay. So I can go and work out the scale factor again because these two guys are just lines. That's a line there, and that's a line there. Okay, so the small one times by the scale factor must equal the big one. So the scale factor within here would be 35 divided by 15. We'll divide top and bottom by 5 to get 7 over 3. So then, to go and get what x is, I look at its corresponding, which is 14, and I'm going from the big to the small. So I want to do, effectively the small one, x, times by the scale factor, so times by 7 over 3, that will give me 14. Okay, so to work out x, I want to do 14 divided by 7 over 3. And then if I'm dividing by a fraction, I know that I can times by its reciprocal, and it will make my life a bit easier. So 14 times by 3 over 7. Again, same trick as before. Put that as a fraction, put it over 1. I'm going to divide top and bottom by 7. So that goes into 14 twice. That goes in once. 2 times by 3 is 6. 1 times by 1 is 1. So the answer is 6 centimetres for the radius here. Now, what that hasn't done is that has not worked out what they asked me to do, which was to calculate the volume of the flask. The volume of that flask, I would use the following formula. It's a cone. So volume of a cone is a third pi r squared h. So using that, have I got some more paper? Oh, not quite. I'll have to write it here. So volume is equal to a third pi r squared h. So we want to do a third pi of the radius of 6 squared times by the height, which would be 15. Okay? Now, I'm going to make my life a little bit easier. I'm going to work out that 3 goes into 15 5 times. And then 36 would be 6 squared. Times by 5, I don't know what 36 times by 5 is. However, if I do 36 times by 10, that would give me 360. 10 is twice as much as 5, so half of that would be 180. So my answer would be 180 pi. Okay? Right, over the page, what we've got, number 20 or page 24, number 11. Let me just sort my papers out so it's nice and neat. Have a quick read of the question. I'll start to go through it in a moment. Okay then, it says a company is building a new headquarters. The diagram below shows the ground plan of the new headquarters. The plan consists of a square and a sector of a circle. Using the information in the diagram, calculate the radius of the sector of the circle. Give your answer in the form A root B, where A is an integer and B is a prime number. Okay. Now, in all honesty, forget about this bit here for now. Okay, that's basically just telling you is your answer right or is it wrong. Okay, which is quite nice in some respects. Okay, so from here, I want to deal specifically with this element here. Okay, now this is a good bit to know here, because we're told what the area is and we know what the angle is at the circle. Okay, now we know to work out the area of a sector, we're going to do the angle out of 360 times by pi r squared, because that is the area of a circle, and that's telling me it's a fraction of that circle. It's the degrees that you have out of 360, which is the full circle. So that is the formula that you should know, area of sector. What I'm going to do now is start substituting in the information I know. I know the angle is 40, so that's going to be 40 out of 360 times by pi. Now I don't know what the radius is, so that stays as pi r squared, but I can put that equal to 200 pi, because I'm told here that the area of the sector is 200 pi meters squared. Next thing I'm going to do is cancel down this fraction, or simplify the fraction, divide top and bottom by 10. 4 out of 36 is the same as 1/9 times by pi radius squared is equal to 200 pi. Okay, the next thing I'm going to do is get rid of this 9 here. I don't like it. I'm timesing both sides by 9 to get rid of it. I'm now going to get pi r squared is equal to 200 pi times by 9, so that would be 1800 pi, or 1800 pi. Now, from here, I'm going to divide both sides by pi to get radius squared is equal to 1800. The pi's effectively just cancel out by dividing both sides by pi. I'm now going to square root to get the radius by itself. So I square root that and I get 1800. Okay. Now, I am looking for a square number that fits into 1800. So I'm going to start writing out my square numbers here. 1 times 1, 2 times 2, 3 times 3, and so on. Okay. Now, in terms of the number that we're looking for the biggest possible number that goes into it. And I don't want to go so far that I'm writing out all my square numbers up until like 50 squared, okay? As long as you know up to about 12 squared, 15 squared would be ideal, okay? Now, if we start looking at 1800, can we spot a square number that goes into it? And I can there. So I'm going to look for that, and I'm going to rewrite this out as 9 times by, now that would be 200. Now before I finish, I'm looking for another square number that could go into 200. So if we look at the 1800, we spotted that. I can spot another one. 100 goes into 200. So I'm then going to split it again to be 9 times by 100 times by 2. If you multiply 9 times by 100 times by 2, you would get 1800. That's all I've done so far. And now I'm going to split each of these, which I can do using rules of surds, into their individual square roots. The square root of 9 is 3, times by the square root of 100, which is 10, times by the square root of 2, would become the answer 30 root 2. Okay, now this is what this line here in pink was telling me. It said A is an integer, so that is a whole number outside the square. And it says B is a prime number, 2 is a prime number, so it's just telling me that I have the right answer. Okay? We're then told, for part B, it says the square is to be covered in concrete. Calculate the area of the square, expand any brackets, and simplify your answer. So they're giving you a huge hint again of what you need to do here. We know what the radius is. We've just gone and found this out. This is 30 root 2 as my radius. Okay? So then, to work out the side of a square, it would be this radius here and 10. So that means I know what this side is as well, because it's a square. It would be 30 root 2 add 10, but I'll put that in brackets because there's two things. So that's basically telling me how to do it here. So I want to do 30 root 2 add 10 squared, which means 30 root 2 add 10 times by itself, 30 root 2 add 10. I now need to expand those brackets, so this one here has to multiply both of these ones in this bracket, and this one here has to multiply both of these ones in this bracket. 30 root 2 times by 30 root 2, so the outsides times each other to begin with. 30 times 30 is 900, and then root 2 times root 2 is just 2, so it's 900 times 2. The next one we've got is 30 root 2 times 10, so that would be 300 root 2. 10 times by 30 root 2 would be 300 root 2 again. And then 10 times 10 would be 100. 900 times 2 would be 1800 or 1800. Add the 100 be 1900. and then plus 600 root 2. Okay, that is the final question, and that was the end of the paper. Okay, hopefully that was useful. Thank you very much for watching, and if it was useful, please hit the subscribe button and you will get instant access as and when I release any more materials. Thank you very much for watching.